this video, we're going to see the rule number 3 in root locus of control systems. The statement for this rule number 3 is a point on the real axis lies on the root locus if the number of open loop poles plus zeros on real axis to the right of this point is odd. Let's see the proof for this. Now, before going to that, let me show you the root locus is nothing but the roots of this characteristic equation when a parameter is varied. Usually it will be k, when k is varied from 0 to infinity. Now in this case, the most important part which helps us in proving this rule number 3 is angle condition, which is like angle of g of s h of s function equals to plus or minus 2q plus 1 times 180 degrees, where q value can be it can take values 0, 1, 2, etc. so on. Okay, this angle condition comes from the fact that if you take g of s times h of s equals to minus 1, if you take angle on both sides, angle of g of s h of s should be equal to, we can write this minus 1, which is 180 degrees. We can write it as 2q plus 1 times 180 degrees, because that minus 1 can be represented with all these angles, where q takes values of 0, 1, 2, etc. so on. This is called the angle condition or angle criterion, because we are plotting the roots of this equation, then it should satisfy this angle condition. And also, if you take magnitude of this g of s h of s, it should be equal to absolute 1, because we are taking magnitude at both sides. That is called magnitude condition. Okay, we'll see these conditions again and again because they're very important, and these two are not independent, they're related. Okay, so if you have a point present on the root locus, for sure that point, if you substitute in g of s h of s and take angle, it should satisfy this condition, and if you take magnitude, it should satisfy this condition. So it should satisfy both angle and magnitude condition. With this basics, we should be able to prove this rule number 3. For this, let me take an example of let me take a pole 0 configuration shown in this S-plane. Okay, let me pick different colors. Okay, now let's take, we have one pole here, okay, another pole here, 0 here, and another pole here. Now the rule number 3 says, if you have a point on real axis, if that point is present on the root locus, then the number of poles and the zero sum to the right side to that point should be odd, right? Suppose let me take a point, say here, okay, in between. Let me take this point and see if this point exists on a root locus or not. Okay, if we take this point, the angle made by this pole here, okay, let me take this P1, P2, Z1 and P3. Angle made by this P1, if you see, it will be 180 degrees, right? Angle made by this P2 to this point will be 0 degrees, right? Angle made by this 0 to this point will be 0 degrees again, and angle made by this P3 to this point will be 0 degrees, right? Now, if you look at the total amount of angle that is made to this point will be equal to angle made by zeros, which is 0, minus angle made by the poles is 180 degrees. Okay, which is nothing but minus 180 degrees. This satisfies this angle condition which we stated here. So this point for sure will exist on the root locus. If you take any point in between these two, P1 and P2, for sure the angle is going to be minus 180 degrees. It means this section which is present in between this P1 and P2 is going to be there in the root locus of this characteristic equation which you are plotting, right? Now let me take this section of the root locus, okay, or let me be precise, let me take this section on this real axis between this P2 and Z1. If I take a point here, for that point the angle made by P1 will be 180 degrees, angle made by P2 will be 180 degrees, angle made by Z1 will be 0, angle made by P3 will be 0. So if I take the angles made by zeros, which is 0, minus angle made by the poles, which is 360 degrees, because one 180 is contributed by P1 and the other is P2. Okay, if we see this, we'll have minus 360, which won't satisfy the angle condition. So this part of the section won't exist on the root locus because it's not satisfying the angle condition. If you look at this third one, okay, third section on this real axis, say, if you look at this point, then the angle made by this pole, okay, to this point will be 180 degrees, right? And from this point, which is P2 to this point, will be again 180 degrees. An angle made by this 0 to this point will be another 180 degrees, and made by this point from this P3 will be 0 degrees. Now if you look at the net angle made by all the zeros and poles in the system to this particular point, let's say P4, okay, let's take P4, okay, so it will be angle made by zeros, here it is 180 degrees, minus angle made by the other poles, which is P1 and P2 will have 360 degrees, right? So it will be minus 180 degrees. This is satisfying the angle condition. Okay, we looked at this example in which first section we had number of poles, sum of poles and zeros to the right half of this point is 1, right? In that case we had root locus existing on that. If you look at this second section, it is not existing because the sum of poles and zeros to the right half of side to this point is even. Okay, if you look at this section, the third section, okay, in which the sum of zeros and poles to the right side of this point is odd, which is 3. So the root locus exists there. Now we have shown that if the number of if the sum of poles and zeros to the right side of a point which is present on the real axis is odd, then the root locus will exist on that particular point or section. Okay, if you have any doubts based on this, please comment on the video or send me a message so that I'll reply back. Thanks for watching.